Now that we understand this concept of normal distribution, we need to understand process capability. Process capability measures how our process will do with respect to the specifications given to us by the customer. So, process capability is a customer oriented metric. So, say I have customers for a process where there is some metric. It could be the wait time, it could be the length, it could be height, it could be weight, it could be any metric. And let's say for this particular metric that my customers give me, this is the x axis for that metric. My mean that the customer has asked me is 20. So this is the mean, which is the x bar. And the customer allows me some variability. The customer says the variability I can have is 26, which I call as the upper specification limit, which is the maximum on the upper side. And the lower limit is 14, which I call as the lower specification limit. And our products need to be majorly, the customers will accept our products only if they are in these limits. So I will create the center line and then I will map out our normal distribution. All right, so this is supposed to be symmetrical on both sides. And the norm here, the standard is that we should fit 3 standard deviations or 3S between the mean and the upper specification limit, and 3 standard deviations between the mean and the lower specification limits. So that's the standard or the norm that we have adopted. Because if we do that, these will be the products which are outside our limits, which the customers will reject. In that case, only 3 out of 1,000 products will be in these limits. Only 3 out of 1,000. If I have to map this, this is going to be 3 out of 1,000. Or if you look at it from normal distribution terminology, the area in this part will be 0.997. So yeah, that's the products which the customers will accept. And so if I have to give you the value of the standard deviation that we should have, so we can do some standard mathematics that the standard deviation should be lower than, okay, standard deviation should be lower than 26 minus 14 divided by 6 because we need to fit 6 standard deviations. Or the standard deviation should be lower than 26 minus 14 is 12 by 6, or standard deviation must be lower than or equal to 2. So this is the idea of CP that we have here. That CP, this is we use when we do Excel in the next video. We'll see that this is how the idea of CP comes up, where we say that standard deviation has to be, there is a calculation of upper specification, lower specification limit. So that's how we measure CP. Now there is one more concept here, because what happens sometimes is that our curve shifts. So for example, let us say we take the same situation. Our customer allows us 20, upper specification limit is 26, lower specification limit is 14. This is where the customer arrives and we work on this process. But because of a malfunction, what happens is, though we are supposed to maintain a mean of 20, we are not able to make a mean of 20 and our mean shifts to 22. So our curve, the new curve that we have, will be something like this. So now what happens is we have a lot more defective on the right side. And that's why it's very important not just to see that the curve is 6 sigma limits are included between upper specification limit and lower specification limit, but to ensure that 3 sigma are included on both sides, or 3 standard deviations are included on both sides. And that is the concept of centered process capability, or CPK, that we will see in the Excel sheet calculations.